Our focus standard for this lesson comes from Grade 7, Geometry, Standard 6. Solve problems involving area and surface area of 2- and 3-dimensional figures. The topic for this lesson comes from AGR, Surface Area of 3D Figures. Our essential question is, how can we use our knowledge of calculating area to find the surface area of 3D figures? Please take a moment, pausing the video if you need to copy down the topic and the essential question in your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. First, let's talk about finding the surface area of rectangular prisms. Bernita is painting the outside of this box for a prop in the school play. She needs to figure out the total surface area of the box to know how much paint she needs. Below is the diagram she drew with the dimensions of the box. So here we can see the box that Bernita is needing to paint. It's got a height of 9 inches, 3 inches deep, and 12 inches wide. So when we're finding surface area, and this might be a review for you, but we want to find the area of each side, and then add each of those together, find the sum, to get the total surface area. Now, one thing with rectangular prisms is they come in pairs of congruent sides. So let's take the top for instance. I've shaded the top red, and the congruent rectangle to the top side would be the bottom. It also has congruent sides on the left and right, and the front is congruent to the back. So I like to list each of those out before I begin my calculations. So as you can see, I've listed those congruent sides here, the top and the bottom, which I've outlined in red, the front and the back, which I've outlined in a thin green line, and the left and right sides. So once I've listed out the sides and thought about them as their separate parts, you might remember making nets from these types of shapes in 6th grade. So paying attention to each of those rectangular parts and how they correspond. Then I like to list out their dimensions. So go ahead, make sure you have this much copied down, and list out what is the length and width for each of these pairs of rectangular sides. Do you agree? I've listed the dimensions of the top and bottom rectangular sides are 3 by 12. The front and back are rectangles that are 9 inches by 12 inches, or 12 by 9, you could have written it either way. And the left and right side dimensions are 3 by 9. Once I've written out the dimensions of each rectangular side, I start to do my calculations. Feel free to go ahead and pause the video here and do your calculations. How'd you do? I got 36 inches squared for the top and bottom rectangles, 108 for the front and back, and 27 inches squared for the left and right sides. However, that's really only calculating the area of one. Each of these are listed in pairs. So since there's a top rectangle with an area of 36 and a bottom rectangle side with an area of 36, I have to multiply this by 2. And I need to do that for each pair of congruent sides on this rectangular prism. If you haven't done that calculation already, please go ahead and do that now. We should have gotten 72 for the combined area of the top and bottom, 216 for the combined area of the front and back, and 54 inches squared for the combined area of the left and right sides. So our final step is to add each of those values together to find the sum for the total surface area. When we combine 72, 216, and 54, our calculations from right here, we come up with the total area, the total surface area, being 342 inches squared. Remember, in area, we always want our dimensions written in the squared format because we're finding how many squares cover the surface of that shape. We can then answer our story problem with a complete sentence stating that Vernita needs enough paint to cover 342 square inches. Let's talk about triangular prisms next. So to find the surface area of triangular prisms, we follow much of the same process. So we start by finding the area of each side, but you can see here I've noted that we have to pay attention to the fact that there are sides with different shapes. So I like to categorize those. And in a triangular prism, we have the triangular sides, front and back bases, and the rectangular sides. Again, you can think back to the nets that you used to make for the prisms in your 6th grade math class. So if you haven't done so already, we can start to list this out just like we did for the rectangular prism. So now I've listed out each of the sides that I need to find, again listing them by congruent sides. So the front and back are congruent triangles, and I've already filled in their dimensions. The base, this horizontal part here, is 5 centimeters, and the height is 6 centimeters. Remember, our height of a triangle always is at the 90-degree angle to the base. So I've filled those numbers into our formula. I could then also start to list the dimensions of the bottom rectangular side. So I noticed that one is here, it's a 5 by 11. There's only one rectangle, which is a 5 by 11, so I've listed it by itself. But I noticed that this triangular face is an isosceles triangle because it has the two equal sides of 7 centimeters. So the left rectangle and the right rectangle are congruent sides, so I've listed them together as a pair. So let's fill in our dimensions and go ahead and do our calculations. For the front and back triangular sides, when I took 5 times 6, I got 30, divided that by 2, and I got 15. So the area of one of the triangles is 15 centimeters squared. But I went ahead and took that value and multiplied it by 2 because the front and the back are both 15 centimeters squared and they are congruent. So multiplying that by 2, they have a combined area, the front and the back, of 30 centimeters squared. The bottom rectangle, the 5 by 11, has an area of 55 centimeters squared. And there's only one of those, so I left that there. The left and the right, they had the dimensions of 7 by 11, which is an area of 77, so that'd be for one of those rectangles. But there are two of them, so that's why I've multiplied it by 2 for the combined area for the left and right sides being 154 centimeters squared. So now, what's our last step? That's right. We need to add these values, 30, 55, and 154, to see what the combined total surface area is for this rectangular prism. Go ahead and complete that calculation if you haven't done so already. The surface area that I came up with in adding those three values together is 239 centimeters squared. So this is how I would lay out my work for finding the surface area of a triangular prism. So we don't necessarily need to calculate the surface area for this discussion, but I do want you to think about, if you are laying your work out like this, how many different rectangular sides would there be when finding the surface area of this prism? This one here. Notice, and I mentioned this once already, that we're dealing with an isosceles triangle as the face of this prism. Remember that there are equilateral triangles as well as scalene triangles, and that might affect which sides are congruent or not, and we really have to pay attention to that when dealing with prisms where not all the faces are the same type of shape. I'm going to leave you with that question, so fill in your drawing and your answer to that question and come ready to discuss in class.